Okay, hello, Honors Algebra 2. I'm sorry that I'm not with you here on this Monday morning or Monday afternoon, but I'm definitely thinking about you. And even though I'm not here, you're still going to get somewhat of the M-Locke experience. We're going to watch a quick video on an application of quadratics, which is projectile motion. So if you take out your green packet and open to pages 5 and 6, I believe, is the application projectile motion handout. And if you could also take out a calculator, we'll need a calculator to do some of these calculations. I'm just going to take you through 2 quick problems, and then you can do some practice on your own. So here we go. An application would be projectile motion. I've said this in the past that when you launch a projectile up into the air, it follows a perfect parabolic curve. And by now that you should know that in this parabolic curve for projectile motion, your A value will always be a negative, less than 0. So that way you get the upside down parabola. The general form for a parabola looks similar to the quadratic form. It is y equals ax squared plus v sub 0 x plus s sub 0. Please take a moment to write that down on your paper now. And I'm going to define for you all of the variables. Y will be the height of the projectile up into the air. X will be the amount of time that has passed since the initial launch. A will be the acceleration due to gravity, and this will always be one of 2 values. Either negative 16 feet per second squared, or it could also be negative 4.9 meters per second squared. And you're going to have to pay close attention to the units in the problem to know which A value to plug into a formula. V sub 0 stands for the initial velocity upwards of the projectile. So when we throw a projectile, it's normally done with some type of initial velocity when it leaves our hands, and then it goes up into the air and comes back down. If you drop a projectile, or if you drop an object from a certain height, there will be no initial velocity, and so the middle term, v sub 0 x, will actually completely cancel out. S sub 0 is the initial height of the object. Sorry for that weird variable s there. That's a little strange that they use s instead of h, but our textbook uses s sub 0. If you notice, you do basically have the general form of a quadratic, y equals ax squared plus bx plus c. I'm just replacing values for a, b, and c, renaming b as v sub 0 and renaming c as s sub 0 for initial velocity and initial height respectively. Let's take a look at an example now. You'll have to excuse my example here. This is a little outdated. When I made this, the Steelers were in the Super Bowl, and Hines Ward still was a player, and so I know that this is a little outdated since the Steelers aren't in the Super Bowl, but we're going to use it anyway. And we're going to kind of set this up in a strange way, if you will. We're going to set this up in a strange way. If we picture this projectile, we have Ben setting up to throw to the receiver in a final play of the Super Bowl. We're going to throw the ball with initial velocity of 32 feet per second. The ball is going to leave his hands at a height of 6 feet, probably because he's a pretty tall guy. And it's going to be caught close to the ground, from the ground, by the receiver in the end zone. So if we could picture this, and my drawing is no good. I mean, my drawing is no good here, but you'll be okay. Here is my quarterback. He is going to take a projectile and throw it up into the air. It's going to come back down, and it's going to be caught by a receiver here in the end zone. So we have a parabolic path represented, and we're going to do some calculations with this parabolic path. We're going to set up our formula as y equals ax squared plus v sub 0 x plus s sub 0. And we're going to plug in 3 values for a, v sub 0, and s sub 0. If you notice, all of our units in this problem are in feet. And since our units are in feet, we're going to choose the acceleration due to gravity, which is basically consistent on Earth, to be negative 16 x squared plus the initial velocity is 32x plus the initial height is 6. There's our equation. And we're going to find how long the ball is in the air. We're going to find this root right here, R1. We're going to find how long that ball is up in the air by calculating the roots. Right now, to calculate roots without a calculator, all you know how to do is complete the square and solve for roots using complete the square. So that's what we're going to do. And if it's okay with you, I usually like my y on the other side of the equation, so I'm just going to reverse my equation, reverse my y. To complete the square, this is a good review from Friday's lesson. We're going to take the constant 6 to the other side of the equation by subtracting 6. Notice we have an a value, and since we have this a value, we're going to have to factor out the negative 16. X squared minus 2x equals y minus 6. Whoa, notice how this sign changed here. When you factor out a negative 16, positive 32 changes into a negative 2. So be very, very careful when factoring out a negative. We're going to complete the square by finding our perfect square to add to both sides of the equation. There's a magic number that makes this a perfect square. We got to figure out what that number is. Well, remember, we take the number 2, we take this little 2 right here, and we divide it by 1, and we square it. So the magic number is a plus 1, and a plus 1 over here, but be so careful to keep it balanced, you need a negative 16. And so if you pay attention here, I have my negative 16 on the left, my negative 16 on the right, to keep everything balanced very nicely. Negative 16, set up your perfect square trinomial, factor it, x minus 1 equals, and then we'll do a little bit of math over here to figure out what negative 6 plus negative 16 is. Negative 22. Bring it together, and negative 16, x minus 1 squared, plus 22 equals y is your vertex form. Our vertex in this case is going to be 1, 22, and the vertex is a very important value in this problem for a projectile because the 22 represents the max height of the ball, 22 feet, and that happens at 1 second once the ball is released from the quarterback's hands. Now we can find our roots. I'm going to take negative 16 times x minus 1 squared plus 22 and set it equal to 0 to calculate roots. Solve by subtracting 22 from both sides. Divide by negative 16. Square root both sides. Do not forget the plus or minus. And finally add 1. These are what are called my exact roots, but I would actually want you to give me a decimal approximation, especially since this is a time problem. So use your calculator right now to calculate what your roots are going to be. Now we have two roots, but only one actually makes sense for the final answer for this question. The question was, how long is the ball up in the air? Obviously, we're looking for the positive root. The negative root is actually back here. We don't want that root. This is your R2 over here. We want this root right here, which is an x-intercept, which is when y equals 0, so the ball is pretty much at the ground. And we know that our final answer, therefore, appropriately would be 2.173 seconds. So really, this isn't anything new from what we did last week. It's just I'm giving you a general form for a projectile, y equals ax squared plus v sub 0 x plus s sub 0, and I'm asking you to plug in some values for a, v sub 0, s sub 0, and still do the same process, complete the square. If you have to rewind this video and look at any part again, I did go through that kind of quickly. Be sure to do that so you understand where each part comes from. I have another question, but this time it's on baseball. And if you notice, we have an initial velocity of 128 feet per second. The ball is hit 3 feet from above the ground. I want to know how long the ball will be in the air, which means you're going to calculate your roots. And then also I would like to know the max height, which means you need to know your vertex. So start with your general form, ax squared plus v sub 0 x plus s sub 0. Plug in your values. This is a feet problem. If it's a feet problem, then we know a will equal negative 16 feet per second squared. Luckily, it's negative because projectiles always go up and then come back down. An initial velocity of 128 feet, initial height of 3. And so using the model that I just did, I would like you to complete the square to calculate the roots. Once you complete that task, keep this handout out, check with the person who's next to you, see if you got the right max height, see if you got the right roots. Once you do, give that person a high five, say, yeah, we got it right, feels good. And then I would like you to finish today's class period by flipping in your green packet over to page 3 and 4, and I'd like you to complete those problems for the rest of the period. I will check this when I see you again tomorrow. So I hope you have a wonderful Monday. I look forward to seeing you again tomorrow. Have a great day, guys. Bye.